So my topic is regarding consequences of bugs. So let's start with the importance of bugs. So the importance of bugs depends on frequency, correction cost, installation cost, and consequences. So let's discuss about the first bug, that is frequency. How often does this kind of bug occur? Pay more attention to the more frequent bugs types. So in correction cost, what does it is cost to correct the bug after it is found? The cost is the sum of two factors, that is, the cost of discovery and next the cost of correction. These costs go up dramatically later in the development cycle when the bug is discovered. Correction cost also depends on system size. Next bug is installation cost. Installation cost depends on the number of installation, small for a single user program, but more for a distributed systems. Fixing one bug and distributing the fix could exceed the entire system's development. Next bug is about consequences. What are the consequences of the bug? Bug consequences. Bug consequences. What are the consequences about? So bug consequences can range from mild to catastrophic. So the next is about the consequences of bug. A reasonable metric for a bug importance is can be calculated as importance is equal to frequency into, that is, multiplication of correction cost plus installation cost plus consequential cost. Next, the consequences of bugs can be measured in terms of human rather than machine. Some consequences of bug on a scale of 1 to 10 are mild. The symptoms of the bug often does aesthetically, that is gently, a misspelled output or a misaligned printout. So the second bug is moderate. Outputs are misleading or redundant. The bug impacts the system's performance. Third is annoying. The system's behavior because of the bug is dehumanizing. Examples, names are truncated or arbitrarily modified. Fourth is about disturbing. It refuses to handle legitimate, authorized, or legal transactions. The ATM won't give you money. My credit card is declared invalid. This kind of disturbing bugs. So the next bug is about serious bugs. It loses track of its transactions, not just the transaction itself, but the fact that the transaction occurred. Accountably, it lost. That is, money can be lost in this kind of bugs. So the next is very serious bugs. So the bugs causes the system to do the wrong transactions. Instead of losing your paycheck, the system credits it to another account or converts deposit to withdrawals. So next bug is extreme bug. The problems ain't limited to a few users. So it ain't limited to a few users or to a few transaction types. They are frequent and arbitrary instead of for unusual cases. Next is intolerable bug. So the long-term unrecoverable corruption of the database occurs and the corruption is not easily discovered. Serious consideration is given to shutting the system down. So next we discuss about the catastrophic bug. So the decision to shut down is taken out of our hands because the system fails. And next and last is infectious bug. What can be worse than a failed system? One that corrupts other systems, even though it doesn't fall in itself, that erodes the social, physical environment, that melts nuclear factors and starts war. So these were the 10 kinds of bugs I have discussed. So the next I'm going to discuss about the flexible severity rather than absolutes. Quality can be measured as a combination of factors, of which number of bugs and their severity is only one component. Many organizations have designed and use satisfactory quantitative quality metrics. Because bugs and their systems play a significant role in such metrics, as testing progresses, you see the quality rise to a reasonable value, which is deemed to be safe to ship the product. So the factors involved in bug severity are, the first comes is The correction cost. Oh, yeah, this one, correction cost. Not so important because catastrophic bugs may be corrected easier and small bugs may take measure time to debug. And next is context and application dependency. Severity depends on the context and the application in which it is used, creating culture dependency. What's important depends on the creators of software and their cultural aspirations. Test tool vendors are more sensitive about bugs in their software than games software vendors. So the fourth is that is user culture dependency. Severity also depends on user culture. Nav users of PC software go crazy over bugs, whereas pros, that is experts, may just ignore. So the last is about the software development phase. That is, the severity depends on development phase. Any bugs gets more severe as it gets closer to field use and more severe the longer it has been found. So it was about my presentation.